Welcome everyone to this session where we're going to look at some version control software called Git. Now I think we can all relate to the problem of having multiple versions of the same document on our computers. It might be multiple versions of the same research paper that we're writing. It might be multiple versions of the same analysis script that we've constructed. And it can be really tricky keeping track of all the different changes between the versions and even sometimes which version is actually your final version. And I think this little PhD comics cartoon over here captures it nicely. It can also make simultaneous collaboration tricky where you might have, a research paper that you're writing and different people are commenting on it at the same time. And it'd be much better if we had a situation where there was just one base document and what we had was effectively a record of all the changes that occurred to that original document. We could then easily see the most recent version and we could easily roll back changes that had been made by effectively reversing those changes. So it's a bit like, using the undo button and cycling through different versions of a document history. So one of the solutions that's really sort of, incredibly useful in terms of addressing this problem is using version control software. So version control software works by tracking the changes that are made to files, and it keeps track of these changes in a special kind of directory called a repository or repo. And by using version control, you're able to roll back to previous versions of your files. And what's really handy is for larger projects, you can actually have multiple people collaborating on the same project simultaneously. So multiple people could, for example, add comments or edit the same document at the same time. What it means in practical terms is that on your computer, you don't have 10, 20, 30 different versions of a document. You've actually got one document saved. And all the changes that are made to that document are actually stored separately. And you can think of that as a diary of changes. So when you take these two things together, you've got your base document and then all the different versions of that document that then you can cycle through. So what's Git itself? So Git is probably the most popular version control tool used now. It was created by Linus Torvalds. If you're into computery stuff, you'll kind of know that Linus was the creator of the Linux system. And it's free and open source, as is Linux. So Git's a wonderful tool that does a very simple job exceptionally well, and it's used widely across the community. Scientists use it, software developers, researchers, both within and outside academia. And these are just some of the countries that actually use Git as a way of version controlling their projects and as a way of allowing different research teams and individuals to collaborate on the same project. And Git is a really important tool in the context of doing reproducible research. So that's Git. So what's GitHub then? So GitHub is basically a Git repository hosting service. It allows you to store your Git repositories in the cloud. It's super useful because it allows you to easily back up all your analysis code, your data, your documents, etc., and allows you to share them with others. You can also have cases where, if you're like me, you've got several computers, you can make sure that each of those computers is synchronized with what's on your GitHub repository. So you can work on the same project on lots of different computers, and you can always be sure that all those computers you're using actually reflect what's in the GitHub repository. So GitHub's one of the easiest ways to make your analysis code and your data open. So we've spoken extensively about the importance of conducting research in an open and reproducible manner. With your research article, when it gets published in a journal, you can actually make your code open and your data open by putting it on GitHub and then generating a DOI using Zenodo. So Zenodo and Figshare are platforms that allow you to make your data and code citable. So once your data is citable, you don't have to really worry then about other people, in quotes, stealing your data. They can actually cite it. And it can be really nice to see other people using your data set in their own research. So we can use Git and GitHub in different sorts of ways. We're going to focus on one particular way in this session. So you can use Git and GitHub as a way of, basically working by yourself, helping keep track of your workflow, helping keep track of the changes that you make to analysis code that you're writing, to documents that you're writing, etc. And it's also, you can think of it as a way of backing up your important work, with minimal effort. Importantly, and this is really where Git and GitHub come into their own, you can use them collaboratively to work as a member of a team with lots of other different members. So we could actually have many different sessions on the ins and outs of using Git and GitHub. What we're going to focus on today, and I think mainly because this is what you're going to find it most useful for at this point in your careers, is we're going to focus on how you can use Git and GitHub yourselves to version control your own projects and to keep track of changes between, data analysis code, documents you might be writing, etc. So you need to install Git onto your computers. I think some machines may come with Git pre-installed. I think Apple Macs do, but it's important to update the most recent version of Git. I've put together a Windows-specific video on how you do this and a Mac-specific video as well, which will take you through the steps one by one. So there are various steps associated with installing Git on Mac. If you want to skip to that video now, please feel free to do so to get Git working on your Mac. And similarly, I've done a video on how you install Git on Windows. So if you're a Windows person, you might want to skip to that video now and then come back to this video once you've installed things. So in addition to getting Git up and running on our machines, we also need to make sure that we've got an account on GitHub. And you might have this already from previous work where you were building binders. So if you haven't already got an account on GitHub, go and create one. If you do have an account on GitHub, go and log in. And what we're going to do, I demonstrate this in the Windows and Mac videos, is we're going to create a new repository, and we're going to call it My First Repo. We're going to add a readme file. We're going to add a gitignore file, and a gitignore file can be really useful because it basically tells GitHub and Git what not to track. So sometimes when you're working with sensitive data or documents, you might end up storing password information, for example, on your local machine, and obviously you don't want that then to be captured on GitHub in the cloud and potentially made public. And there's a whole bunch of default gitignore files that you can use. There's one for R, there's one for Python. You can actually create your own. So it's really important to use a gitignore. When you're making your data and code open, you want others to be able to use it. So you need to tell them how they can use it. And you do that by choosing a license. I tend to use the MIT license for everything I do. It's one of the most permissive licenses in terms of allowing use and reuse by others. So once you've done all that, you just click on the Create Repository button, and your repository is created. And you'll see there we've got our gitignore file, we've got a license, and we've got a little readme. The .md tells us that's written in Markdown. Okay, so we've got our repository in GitHub. Now we want to get it onto our computer and to connect our computer's version of the repository with what's on GitHub. So the first thing you need to do to connect your GitHub account with your local machine is create a personal access token. This is like a unique digital key that identifies you and allows you to connect your GitHub account with the repositories on your local machine. I'm not going to sort of tell you how to do that because there are really great documents and guides on GitHub itself, which shows you how to create an access token. And you probably just want to make sure when you're creating your token, you give it the rights to delete repositories that you might want to do from your local machine. But as I say, there are extensive instructions on the website. You get a very long alphanumeric key. That's your personal access token. You probably don't want to be typing that in every time you're interacting with GitHub from your local computer. So you can also store that personal access token as part of your Git credentials, and it differs slightly from one machine to the other in terms of the easiest way of doing this, but you can go to this link here just to read up about how you store your personal access tokens. So you don't have to keep logging into GitHub each time you're interacting with it from your computer. So if we click on the code button on the top right of a repository, we get a link here, which we can just copy into our clipboard by clicking on this little button here. And what we're going to do, if you're on a Mac, you'll open up a terminal window. If you're on a Windows machine, you'll open up a PowerShell window. Navigate to where you want your repository to be cloned to. So you can use the command cd to change directory. cd is the same command in both terminal and PowerShell. So navigate using cd to where you want to clone your repository. Now, if you're not familiar with using terminal or PowerShell, just have a little bit of a Google to familiarize yourself with some of the useful commands. So once you've navigated to where you want to create or to clone your repository that's in GitHub, you then simply type in the terminal or PowerShell window, git clone, and then paste in the address, press return. You might be asked to enter your username and your personal access token, depending how you've set things up. And what this will then do is clone your repository that's on GitHub and create a local version of your own machine. So what we've got is basically our local machine and our repository on GitHub now synchronized. And as I say, go to the this link here to find out how to store your credentials, so you don't have to keep logging in every time you're interacting with Git in the command line. So again, this is in the Mac and Windows videos. We're going to create a new file in our Git repository. We're going to do that using a simple text editor. And we're going to create a new file which simply contains one line, which just says hello world, and we're going to save it in our Git repository on our computer. So we've created a new file. Now we want to make sure that that new file is captured in our Git history. So first of all, we're going to add that file to our Git repository, our diary of changes. We're going to commit that file with a message which captures something meaningful about the work that we did in creating that file. So a meaningful message associated with the changes that you've made. And then we're going to push from our local Git repository to the cloud version of the repository on GitHub. And we do that with 3 commands. So we can stage or add our changes with git add -- all will actually stage or add all of the changes in the repository on our local machine. You can replace this with just the file name if you want. We're going to say git commit -m, which means this is a message. And it could be something like, this is my first commit, or I've created the file, my new file, or something like that. And then we click on git push, and all being well, the changes then that we've made on our local machine suddenly appear on the GitHub repository in the cloud. So you can kind of see then that our two repositories, the local repository and the GitHub repository, are basically the same. So we can see that we can click on the file because it was text file. If we click on the file, we actually get the contents of the file displayed on GitHub. If we click on the history icon in the top right, which is up here, you'll see the history of commits that we made. And each of these commits has got a special identifier associated with it. And if we actually clicked on one of these identifiers, it would actually tell us about the changes that were made during that git commit. And we can see in this case, we're going to actually we're going to edit our text file, and I do this in the video, and we're going to add another line which says, and hello universe. If we make that change and push it, or commit it rather, we can then see that the file has had 2 additions in that second commit, a blank line and this line here which says, and hello universe. And we can kind of see those changes reflected if we click on the history button again. We can kind of cycle through the different iterations of the file. We can also edit our readme file to contain useful information about the repository. If you've created a repository that then you've linked to Figshare or Zenodo to make it citable, you might put the DOI in here, and you might have a little bit of a description as to what the repository is actually about. And the README you write in Markdown, so you're familiar with Markdown because you've used it. You've used a particular version of Markdown called R Markdown in your various R assignments, but Markdown itself is a much more general language, and you kind of know the syntax already because you've been using it. So we can edit our README, we can add a little bit of text, and then we can add a message to the changes reflecting the change that we've made, click commit changes, and then those changes will be reflected. So now our repository has actually got an updated README, so on GitHub in the cloud, we're actually 1 or 2 commits ahead of what we have on our local machine because we've got the updated README and we've got the updated my new file, with the additional and hello universe line of text. So our GitHub repository is now, I think it's actually 2 commits ahead of our local repository. So what we need to do is basically resync our 2 repositories to ensure that our local repository is up to date and then reflects these new changes that occurred on GitHub itself. So the opposite of git push, which is when we're pushing from our local machine to the cloud, is git pull, where we pull from the cloud changes to our local machine. And again, we interact with that via terminal on a Mac or PowerShell if you're on a Windows machine. And you can navigate to the local repository on your computer and then just type git pull, and that'll bring the changes from the cloud and update your repository on your local machine. So your local machine will now have the exactly the same contents as what's in the cloud. And it's worth remembering in both cases, you've got your Git history, so you can kind of cycle through all the different iterations of your repository. So in summary, Git is an incredibly powerful tool for version control. You never have to worry about which is the final version of something you've written, because you can have just, the one document version controlled, which allows you to always be able to access the final version, but importantly, be able to see all the changes that are made as you were on your journey to that final version. And if you combine Git with GitHub, it's a perfect environment for collaborating with others, both within and outside your organization. You'll be able to work on large-scale global projects and be part of this broad community of researchers, coders, and data scientists who all use Git and GitHub in their everyday lives when it comes to work. I don't know anybody who doesn't use version control who's a serious sort of data analyst. And we've really only just scratched the surface here about what Git and GitHub can do for you. There's a whole, several hours worth of content where you can go and explore how you can use Git collaboratively. If you're interested in reading up more about Git, you can just go to this website here. And if you're interested in more about GitHub, you can go to this website below. Okay, so that's kind of a bit of a brief introduction to the wonderful world of version control using Git and GitHub. In the next few videos, I'm going to show you how you can use Git in the context of RStudio. There's a nice little interface built into RStudio that allows you to do version control. And I'm also going to show you how you can do version control with respect to a Python project that you might be working on, where we'll be focusing on using Git in the command line, which is terminal or PowerShell.